we are going to learn a new way to solve a system, and it's called elimination. And we use elimination when we have two equations that are in standard form. So you can see a number times x plus a number times y equals a number, and so on, right? Number times x plus a number times y equals a number. That's how all of these systems are going to be. And here's what we do. When we solve by elimination, the goal is to eliminate, right, that's why it's called elimination, to eliminate one variable. So you have an equation with one variable to solve first. And we saw this, right? This is a 1. We saw this with substitution as well, where we needed to solve an equation that had just one variable first. Now, in order to eliminate a variable, the coefficients of that variable must be opposites. Okay, they must be opposites. Now, what's a coefficient? The coefficient is the number that's being multiplied by the variable. So like here, the coefficient is 3. This is the coefficient, okay? And sometimes the coefficient is negative. So 3, for example, 3 and negative 3 are opposites. So this would be an example of coefficients that are opposites. Okay, so opposites is like negative 2 and positive 2, like that. Okay, now once you get the value of one variable, you just do what we've been doing all along. You plug back in to find the value of the other variable. Okay, and that has been true. That is always going to be true with systems. We need the value of two variables. Often we have a strategy that helps us find one value first. Let's take a look here. So if I look at this system of equations, here's what I notice. I notice that this is 7x and this is negative 7x. So these variables have coefficients that are opposites. So here's what's going to happen. I'm going to add these two equations together. Right now, here's something we've never done before. We're going to take these two equations and we're going to add the equations together. Now, the reason we can do this is because everything's all lined up. See how the x's are above the x's and the y's are above the y's and the constants, the numbers without variables, are above each other? This means all the like terms, these are like terms, are lined up and we can just add them. So what happens when we add here? This is 7 plus negative 7. What is 7 plus negative 7? It's the same as 7 minus 7, and it's 0. So this cancels. I'm left with 0x, or just 0 here, and I'm not even going to write it. Now I'm going to add here. This is negative 1y plus 5y. That's the same as 5 minus 1, and that's 4y. Here, this is negative 10 minus 6. 10 negatives, another 6 negatives. That's a total of 16 negatives. Now look what I have. I have a one-step equation. I know how to solve this. Y is being multiplied by 4. So I'm going to divide by 4. And I get y equals negative divided by positive is negative. 16 divided by 4 is 4. So my y is negative 4. Okay? So I have my one variable, which is great news. And now what do I need to do? I need to plug back in to find the value of the other variable. So far, let's just write down what I have so I don't lose track. I have my y value is 4. I'm going to take this, I'm going to plug it back into, you can plug it into this equation, or you can plug it into this equation. And what you really want to do is plug it into both and check. But let's start with just one equation. Let's plug it into this top equation. So this says 7x minus, and I'm going to write this 1. This is minus 1y. I'm going to write minus 1, and instead of y, right, this is negative 1 times y. I'm going to write negative 1 times negative 4 equals negative 10. Now I'm solving. I want x, right? I already have y. And I'm looking for x. So let's do this multiplication. Negative times negative is positive. 1 times 4 is 4. I'm going to go ahead and subtract 4 from both sides because I'm trying to get x by itself. Divide by 7. And I get x equals negative 2. So I'm going to put my negative 2 right here. Let's just quickly check it really quick. I'm going to plug into this equation. So I have negative 7. I got my x value is negative 2. Plus 5y, so 5 times my y value. And let's just make sure this works. Negative times negative is positive. This is 14. And then this is 5 times negative 4 is negative 20. And is 14 minus 20, does that equal negative 6? Sure does. So my answer looks good. Here's another example. Here I have 1x and negative 1y and positive 1y. Am I ready to add these? Yeah, I am. Why? Because the coefficients are opposites on the y, right? Notice they're not on the x, right? Over here, the coefficients were opposite on the x. So what happened? X got eliminated. Over here, the coefficients are opposite on the y. So this time the y is going to get eliminated. That's okay. I'll find the value of x first this time, right? Because when I add these equations, I get 1 plus 1, that's 2. That's 2x. This is negative 1 plus 1. That's 0, right? I'm not even going to write that. And 4 plus 2 is 6. Now I want x by itself. I'm going to divide by 2. And I get x equals 3. So I'm halfway done, right? I have my x value, and I'm still looking for my y value. So let's plug back in. I'm going to, and look, here's what I noticed, right? I said I can plug in here, or I can plug in here. I like positive numbers, so I tend to just kind of look and see like which equation is going to be easier for me to plug in. So this is x equals 3. This says x plus y equals 2. So I'm going to write x plus, right, x plus y equals 2. I want y by itself. I want to know what the value of y is. So I'm going to go ahead and subtract 3 from both sides. And I get y equals negative 1. Okay, and once again, I'm just going to check really quick. And what I'm going to do is I'm going to use the other equation. I use this one to solve. I'm going to use this one to check. So I get x minus 1y equals 4. Negative 1 times negative 1 is positive 1. And is 3 plus 1 4? Yeah, sure is. Okay, so my answer looks good, and I'm ready to go ahead and try these practice problems.